Greetings, and welcome to the LifeGate Sound PreSonus StudioLive 24.4.2 Digital Performance and Recording Mixer Training, Part 1. This training module is intended as an overview of the PreSonus StudioLive 24.4.2 mixer. It has been developed for use by the sound and tech teams at LifeGate Church. After you have viewed this training module, please proceed to Part 2 to complete the training. LifeGate Sound is making a transition with our sound reinforcement and recording from analog mixing with direct CD recording to digital mixing with direct to PC digital audio workstation multi-track recording. This digital system consists of the following components. Component number 1. The PreSonus StudioLive 24.4.2 Digital Performance and Recording Mixer. This mixer allows for simultaneous live sound reinforcement and true multi-track digital recording through a bidirectional FireWire connection to a high-performance PC equipped with Digital Audio Workstation or DAW software. In effect, this digital mixer and PC combination can do the jobs that previously would have required two separate mixers, one for live mixing and one for recording tracks from a live performance. The SL24.4.2 can do both of these tasks simultaneously and do them well via the FireWire interface and appropriate DAW software. Component number 2. The PreSonus Virtual StudioLive, or VSL, mixer control software. The VSL is PreSonus's proprietary mixer control software. It is installed on the Audio Workstation computer and allows for real-time direct control and customization of the mixer. It provides the ability to easily store and recall an unlimited number of scenes and other parameter settings directly from the Audio Workstation computer. VSL also has an associated StudioLive remote application for the iPad and an associated QMix application for the iPhone, which allow for true remote control of many of the mixer functions via a Wi-Fi connection to the Audio Workstation. Component number 3. The PreSonus Studio One Digital Audio Workstation Software. PreSonus Studio One Professional DAW software is a powerful, professional, multi-track audio mixing and mastering program. Although very feature-rich, via the use of user-defined templates, common weekly recording tasks can quickly and easily be initiated. Final mixdown occurs at much higher speeds than the original recording. A typical sermon, with some added inputs and effects, should mix down in approximately 1 minute. Should there be sections of a message where corrections need to be made, these can quickly be done post-recording prior to the final mixdown. Component number 4. PreSonus Capture Software. PreSonus Capture Software is a simplified, proprietary digital multi-track recording application. It only works with the PreSonus family of mixers. It can be launched rapidly and will record up to 26 tracks simultaneously from the PreSonus SL24.4.2 mixer. Audio tracks recorded in Capture can be imported directly into the Studio One DAW for post-recording mixing. We will not be using Capture for recording sermons at this point. Rather, the more feature-rich Studio One will be pre-configured with the appropriate templates for recording the spoken word. Let's take a moment to review the PreSonus products, as the names and acronyms can get confusing. The PreSonus StudioLive 24.4.2 digital mixer. We will be referring to this by the abbreviation SL24.4.2. The PreSonus Virtual Studio Live software. It is usually referred to by the acronym VSL. It is the software which allows for computer control of the SL24.4.2 mixer, including the ability to quickly recall preset audio scenes via a click and drag with the mouse. The PreSonus Studio One DAW software. The professional-level digital audio workstation program which we will be using for regular weekly recording needs. It is often referred to by the acronym S1. And the PreSonus Capture software, a basic multi-track proprietary recording program specific to the StudioLive line of mixers. The purpose of this training is to present an overview of the layout and functionality of the SL24.4.2 mixer. The PreSonus software components will not be covered here. For ease of viewing during the remainder of this training, the horizontal size of this photograph of the SL24.4.2 has been expanded. Let's get started then with our overview of the SL24.4.2. We'll be starting at the top of the mixer and then work our way around it in a counterclockwise fashion. Starting at the top of the SL24.4.2, we find the input channel trim knobs, 48-volt enables, and firewire return enables. We are starting at the top of the mixer, since that is where the input channel signal paths originate. Channel trims, or trim knobs, sometimes referred to as gain adjustments, are essential to proper mixing. They are used to set the input signal strength on each channel to an appropriate level. Too much signal, and the output of that channel will be distorted. Too little signal, and the sound will be weak. Proper input level is the foundation on which the remainder of the audio mix is built. The input channel trims should be set such that the input signal meters show strong signal but without clipping. Clipping in the SL24.4.2 can occur when the input signal passes the 0 dB setting on the level meters. The SL24.4.2 has 48-volt phantom power available on all 24 input channel XLR jacks. The 48-volt phantom power is only used for certain types of microphones referred to as condenser mics. In order for these types of mics to function, they need an external DC power source. Usually, the power is supplied by the mixer via the microphone cable. The 48-volt enable should only be activated for channels with condenser mics. All other channels should have this switched off. In some limited cases, damage could be caused to a mic or other input device should 48 volts be enabled unnecessarily on a channel. The SL24.4.2 has individual 48-volt enable buttons for each of its 24 input channels. Also note that the 48-volt phantom power is only applied through the XLR inputs on the rear of the mixer, not the line inputs. The SL24.4.2 mixer uses a FireWire or 1394 connection to not only stream audio to the audio workstation computer, but also to return DAW processed audio back into the source channels. When a channel FireWire button is enabled, DAW processed audio for that channel will be inserted back into that channel and will replace the original channel signal at the channel output. What will then be heard for that channel over the loudspeakers will be the DAW processed sound. The next section of the mixer, which we will examine, is the Aux Bus section. The SL24.4.2 has 10 aux buses. Aux is short for auxiliary. The aux buses are normally used to provide signal for the stage monitors, or in some cases for sending mixed signals to external processors or recording devices. When used for stage monitors, they provide a way to create mixes which are separate from what will be heard over the main speakers. For instance, the drummer may want to only hear his drums, the leader's vocal, and the leader's instrument, with very little of anything else. The leader, on the other hand, may want a monitor mix that has only enough of the drums in it to keep the beat. At LifeGate, we currently use 5 aux mixes for monitors. They have been marked on the board itself. Aux 1 is instrument 1 for the leader. Aux 2 is for the vocalists. Aux 3 is instrument 2 for the keyboardists. Aux 4 is for the drummer. And Aux 5 is for the bassist. We are also using Aux 9 and 10 as sends for special recording purposes. The first feature of the aux buses, which we will examine, is the Aux Output Knob. The Aux Output Knob is the master volume for a given aux bus. Adjusting it affects the output level of that particular bus. Note that the knob here is set to U. U stands for unity gain. This is the same as saying that the output of the aux bus is neither boosting, amplifying, or reducing, attenuating the input signals. In other words, unity is a signal multiplication value of 1. Typically, when setting up an aux bus, we will set the aux master output to unity. Then we will adjust each individual input being sent to that bus to an appropriate level. The setting of aux bus input levels will be discussed later in this presentation. The next feature is the solo button. To solo a bus or channel allows the sound technician to listen to just that signal, or possibly that signal and other selected signals, for the purpose of adjusting relative levels, checking for problems with the signal, etc. The soloed signal is usually monitored through headphones or monitor speakers in an audio control room. A soloed signal can also be monitored by the technician without disturbing the mix being heard over the mains. A soloed mix is sometimes referred to as a Q mix. From here, the soloed signal passes down to the solo bus section of the SL24.4.2, where the Q or solo master volume is located. The Q master volume controls the summed volume of the individual solo buses. From there, the summed solo buses pass to the monitor bus of the SL24.4.2. We will cover the solo and monitor bus control sections in more detail later. Note, many of the channels and buses can be soloed as pre-fade listen (PFL) or after-fade listen (AFL). However, when soloing the SL24.4.2 aux buses, the only available mode is PFL. Auxes can be set up to either include or to bypass the channel dynamics, equalization, and channel fader sections of the SL24.4.2. This choice is made via the aux post button. When activated, it indicates that the signal from that particular aux is post dynamics, post EQ, and post fader. For example, when post is activated, an input channel's signal routed to an aux bus will first pass through that input channel's volume fader prior to being sent to the posted Aux bus. Post mode is therefore not a good choice for Aux buses which will be used to feed stage monitors, as any change to an input channel's fader when controlling the main loudspeaker's volume will also decrease the signal going to the Aux bus. Needless to say, musicians do not welcome unplanned changes to their stage volume. When the post button is not illuminated, the aux can be in either Pre-1 or Pre-2 mode. Pre-1 means that the aux signal is taken from an input channel prior to most of the dynamics in EQ and also prior to the channel fader control. Alternately, Pre-2 mode means that the aux signal is taken from the channel after the dynamics and EQ settings, but prior to a channel's fader setting. When using pre-mode, the Pre-1 or Pre-2 selections are set independently for each aux bus via the Master Control section of the SL24.4.2. The Master Control section will be covered later in this training. Note, for the auxes that are feeding our LifeGate stage monitors, we will mostly be using Pre-2 mode. Having finished our discussion of post, Pre-1, and Pre-2, we will now be introduced for the first time to the Select button. All 24 input channels, all 10 auxes, and several other buses on the SL24.4.2 have a Select button. These buttons illuminate blue when activated. When Select is activated for a given channel or bus, access to a special section of the mixer is enabled. PreSonus calls this special section the Fat Channel. The Fat Channel is an expanded set of controls specific to the selected channel. These controls include signal dynamics, EQ, and other essential control functions. Remember that name, Fat Channel. We will be covering it in detail later in this training. Lastly, we come to the mix and mix pan functions for the aux buses. Activating the mix button via a single button press, similar to Select, activates access to the Fat Channel controls for that specific aux bus. However, the control set that it accesses is not the same as that accessed via the Select button. Rather, a single press of the mix button accesses the send to aux levels for each individual input channel. These are set via rotary encoder knobs in the Fat Channel. Each of the 24 meters and rotary encoder knobs control the send from one of the 24 input channels. When the mix button is already illuminated and it is pressed a second time, the mix changes to the aux flip mode so that the remaining aux bus inputs can be accessed. These are level settings for the firewire input, tape input, aux input A, aux input B, FX-A, FX-B, and talkback microphone. These use the same encoder knobs as used for setting the aux input levels for input channels 1 through 7, now repurposed to the 7 buses just listed. A final push of the mix button turns off access to the Fat Channel mix functions. Note that the mix button for Aux Bus 2 has a different label than that for Aux Bus 1. This is also true for all the even-numbered aux buses 2, 4, 6, 8, and 10. When all of the aux buses are running as independent buses, activating the Mix Pan button on the even-numbered buses causes the same results as pressing the mix button on the odd-numbered buses. However, aux buses can be linked, which puts them into stereo mode. When auxes are thus stereo-linked, the mix button on the odd-numbered bus controls the aux input levels for both buses in the stereo pair, while the Mix Pan button on the even-numbered bus sets the stereo balance for that bus pair. The SL24.4.2 has two internal digital effects engines, abbreviated by the letters FX. They are labeled FXA and FXB. Their controls are located at the end of the row where the 10 Aux Bus controls are located. The controls for the internal effects engines are almost identical to the Aux Bus controls. One difference is that the solo button has been replaced with a mute button. The mute button kills the output of the FX bus without having to turn down the FX output knob. Another notable exception is that the FX bus mix button will only allow a single push to activate it. The next push will turn it off. This is because aux flip mode is not available on the FX buses. The choice of effects, such as reverb, delay, etc., is made through the master control section of the SL24.4.2. Since each FX bus can have its own effect selection, two independent effects can be used simultaneously. Now we come to what is the most powerful section of the SL24.4.2 console. As already mentioned, PreSonus has named this the Fat Channel. The Fat Channel is actually not a channel per se, but is rather a section of the mixer which is used to control the generous signal dynamics, processing, and routing capabilities for each channel or bus over which it has jurisdiction. To build an analog board with all the capabilities which the Fat Channel supplies would require very long input channel strips, as well as a significant amount of external processors for each channel or bus. The Fat Channel is therefore a control interface between the user and the powerful signal processing and routing provided by the SL24.4.2. Other digital mixers use video screens with nested layers of software controls. In contrast, by means of the Fat Channel, the SL24.4.2 provides actual physical controls, giving a more analog feel to the mixer. Anytime you press the select button on a channel or bus, the mix button on an aux bus, or the GEQ button above the mains fader, you are enabling Fat Channel control for that specific channel, bus, or device. The Fat Channel consists of 24 multifunction meters with associated rotary encoders, as well as selection and control buttons. These are used for the following: monitoring the input levels to the 24 input channel strips, monitoring the output levels of the 24 input channel strips, monitoring gain reduction applied to the 24 input channel strips, monitoring the aux and FX output bus levels, locating faders for recalled scenes, setting channel and bus dynamics, high-pass filter, noise gate, expander, compressor, limiter, and 4-band fully parametric EQs, setting the 31-band graphic EQs, a total of 8 assignable graphic EQs, setting the channel send levels to aux buses 1 through 10, setting firewire input levels to aux buses 1 through 10, setting tape input levels to aux buses 1 through 10, setting aux inputs A and B levels to aux buses 1 through 10, setting internal FX A and B levels to aux buses 1 through 10, and setting talkback levels to aux buses 1 through 10. Additional Fat Channel controls include pan control, stereo link control, channel copy load save, channel output assigns, and selected channel indicator. Of special note are the rotary encoders. the blue-capped knobs within the fat channel. These are actually not standard pots or potentiometers, although these rotary encoders do work similarly to pots. They do not have a defined stop or start point. Due to this, saved scene settings can be quickly restored to the fat channel without concern for the position of the encoder knobs. All that matters is that turning an encoder clockwise increases a digital value assigned to it, and turning it counterclockwise decreases the digital value. Many radio controls on modern automobiles work in the same manner. Note, only the knobs in the fat channel are rotary encoders. The other knobs on the SL24.4.2 are standard potentiometers. As we have just seen, the name FAT seems quite appropriate, as the fat channel is stuffed with control features. Since the fat channel indeed is quite fat, we have been taking it in bite-sized chunks. We've already discussed the Aux Bus input controls located in the fat channel, which are accessed via the aux mix buttons. Now we'll begin to dive into the fat channel in more detail. The next few slides will cover the following fat channel features. Dynamics, which include the high-pass filter, noise gate or expander, compressor, and limiter. Fully parametric EQ or equalization. Signal routing, and channel scene management functions. The channel metering, fader locate, and GEQ, graphic equalization, functions of the fat channel will be discussed later. Here's a close-up of the left section of the fat channel. In this photo, we see the high-pass filter control and the noise gate controls. These are accessed via any of the select buttons. The multifunction meters above each rotary encoder indicate the degree of adjustment which is being produced by each encoder. In addition to the meters and rotary encoders, note the following. The phase invert button. This changes the phase of the input signal by 180 degrees. The digital output post button. This selects between pre and post configuration for the channel firewire output. The noise gate expander control buttons. Key listen, on, and expander. Rotary encoder 1 sets the frequency cutoff of the high-pass filter. The setting level will be displayed on the multifunction meter above the encoder. A high-pass filter significantly attenuates or reduces audio frequencies below the selected set point. Only frequencies higher than the chosen cutoff frequency will be allowed to pass through the selected channel without attenuation. For instance, with a vocal mic, it is often desirable to significantly attenuate frequencies below 75 Hz. Rotary encoders 2 through 6 set the levels of various gate parameters. The setting levels will be displayed on the multifunction meters above each encoder. A noise gate is used primarily to remove unwanted low-level background noise from an audio signal. An example of this might be hiss coming from a guitar amplifier. The hiss is usually only noticeable when there is no sound being made by the guitar. The noise gate can effectively remove this noise, creating a near-dead silent signal when the guitar is not being played. There are 3 control buttons at the bottom of the noise gate section. Of special note is the expander function, labeled the EXP button. An expander is a more sophisticated type of gate and produces a much smoother, more natural sounding effect. For most situations at LifeGate, we will be using the expander function. The on button is used to either enable or disable the gate. When disabled, none of the gate functions are active, even though the settings can be changed. Here is a close-up of the middle section of the fat channel. In this photo, we see the compressor and limiter controls. These are accessed via any of the select buttons. A compressor is used to compress the volume of a signal. It does this by reducing the volume of the loudest portions while leaving the quieter portions unchanged. This then enables the entire signal to be turned up to make the quiet sections louder, without the loud parts being overwhelming. A compressor does not stop a loud signal from getting louder, it just reduces the amount of the volume increase. For instance, if the compressor ratio is set to 2:1, any signal past the compressor threshold level would only increase half as much as it would without compression. So a signal 10 decibel past the threshold would only produce a 5 decibel increase in volume. The SL24.4.2 also has a limiter function. Unlike a compressor, a limiter is a brick wall. It provides a dead stop to volume increase. The signal output will be limited to some absolute value. Limiters must be used carefully as they can distort sound. Both the compressor and limiter sections of the SL24.4.2 can be turned on or off via their on buttons without having to change any of the individual settings. We have now arrived at the right side of the fat channel. Here we see the entire 4-band Parametric EQ section. The term band refers to a frequency range. For the SL24.4.2, the ranges are the low, low-mid, high-mid, and high ranges. This EQ is fully parametric. This means that each band has adjustments for frequency center point, frequency bandwidth, also known as Q, and gain. At LifeGate, our previous analog mixers were only semi-parametric, meaning that they had frequency and gain adjustments, but no Q, and for some ranges, they had only gain adjustments. Here are some EQ concepts worth remembering. Positive gain is also known as boost. Negative gain is also referred to as cut or attenuation. The term bandwidth here refers to a range of frequencies. A higher bandwidth covers a wider range of frequencies and vice versa. Q is the measure of the width of the frequency band being affected. Q is inversely related to bandwidth. The higher the Q value, the more narrow the affected bandwidth, and vice versa. All 4 bands on the SL24.4.2 have the same basic controls. The low and high bands also have additional buttons labeled shelf, which is short for shelving. A shelving EQ boosts or cuts an entire section of frequencies at the end of a frequency spectrum. Hence, there is a shelving option for both the low and high bands. There are separate on buttons for each of the 4 EQ bands, enabling each section to be turned on or off independently of the others. Of special note is the EQ Master On button for the entire EQ section. This button makes it very easy to disable the entire EQ section all at once, even when individual bands are turned on. It is a very convenient feature when comparing a channel's EQ'd signal to its non-EQ'd signal. A word of caution: when using the EQ section, be certain that the EQ Master On button is activated, or your individual EQ settings will have no effect. The lower section of the fat channel contains essential signal routing and channel management controls for each channel or bus. As with the other fat channel settings, these controls are accessed via the Select button, which is present for all channels and buses which have fat channel access. First, we see the selected channel display. This provides a convenient indication of the currently selected channel without having to look around the mixer. Here are the designations used by the display. The numbers 1 through 24 indicate that one of the 24 input channels is selected. The designations S1 through S4 indicate subgroups 1 through 4. The designation MA indicates the mains bus. The designations A1 through A10 are for aux buses 1 through 10. The designations A11 and A12 indicate the internal FXA and FXB buses, and the designations F1 and F2 indicate the aux inputs A and B. Next, we come to the routing or assignments controls. These control the output destinations for the channel and bus outputs. Press a button to enable and assign. Press it again to disable it. Note the following conventions. The 24 input channels can be assigned to any of the subgroups or mains. The subgroups can be assigned only to the mains. The pan control works in conjunction with the routing buttons. An important point to remember is that a typical analog mixer has separate assigns and pan included in every channel strip and applicable bus. However, with the SL24.4.2, you need to access these functions through the FAT channel, which requires first enabling the select button for that channel or bus. In the lower center of the FAT channel, we find the channel management buttons, Copy, Load, and Save. Via these buttons, FAT channel settings from one channel can be quickly copied and pasted to other channels. Also, they can be used to save or load FAT channel settings. This is very convenient when trying to set up identical channels. Lastly, to the left of the channel management buttons, we find the Link Stereo button. All of the 24 input channels, aux buses 1 through 10, and the subgroups can be stereo-linked in pairs, with each odd-numbered channel or bus being able to be stereo-linked to the next higher even-numbered one. It is important to keep in mind that the meters and rotary encoders of the FAT channel are multifunctional. In other words, the same knobs and meters have different functions depending on the particular functional mode of the FAT channel. These various modes of operation are accessed via the Select, Mix, Mix Pan, and GEQ buttons. For this reason, each meter in the FAT channel will have multiple labels, and they will all differ from each other, as you most likely have already noticed. For instance, with what we've already learned about the FAT channel, we can deduce some of the possible functions for the first meter-rotary encoder combination. From our previously learned knowledge and from the labels, we can know that this combination is used to set the cutoff frequency for the high-pass filter. Note the high-pass filter, frequency, and hertz scale labels. Set the firewire to aux bus sends levels. Note the firewire icon. Set the channel 1 to aux bus sends levels. Note the number 1. There are even more functions performed by this and the other meter encoder combinations. These will be touched upon later in this presentation. You have reached the end of Part 1 of this training presentation on the PreSonus StudioLive 24.4.2. Please now proceed to Part 2 of this training.